All right, welcome everybody to another episode of TGI Kubernetes. I'm your host, Joe Beda. I'm the CTO of a small startup called Heptio. Our mission is to bring Kubernetes to a wider audience, enterprises and beyond. And TGI Kubernetes is a weekly live broadcast that myself, sometimes Chris Nova, more and more lately, do, where we explore a new topic in Kubernetes, a new complementary technology, get hands on keyboard, play with it, and see what's going on. So the notes there, so that's, oh no, I pasted the wrong thing there. Let me fix that. So we have, as we do this, we have, let me, TPS j.hept.io/tgik live notes. So if you go to that URL, j.hept.io, while you're watching this, you can help take notes live. We're going to post these things and check them into our repo later. And so it's a good way for us all to take notes. You can also see a little bit of a preview of some of the stuff that we're going to be covering today. So first of all, I want to give a shout out to everybody. I got my sidebar here fixed from last time, so hopefully folks can see all the things scrolling there. So let's see. So we have Elisiano, welcome. You were on early. We have ADEESEN, Decent from Russia, welcome. Lamati, good to see you. Walid from Libyan, good to see you. Ola from Copenhagen, hele, Vink, nice to see you. Steve, one of the Heptonians that's working on the project that we're going to be covering today. Thanks for joining us, Steve. Julian from Stockholm, Roy from Toronto, Nadir from London, H is from Virginia, Roy from Norway. I love you guys are spending your Friday night with me. I really appreciate that. Anand from, let's see, so keto diet seems to be working. Yeah, I'm on the keto diet, so I eat Diet Coke and like meat and cheese, and I'm losing weight. It's kind of crazy. Leonardo from Brazil, which I think that diet would work well in Brazil. All I know is they eat a lot of steak there. Mark from Australia, from Melbourne. Michael from Jayburg, and then Mike from New Jersey. Good to see you all. All right, so what we're going to be covering today is this project that we started at Heptio called Heptio Contour, which is an Ingress controller for Kubernetes. And we've had a couple of releases since last we did this and really introduced some exciting features. And so I'm going to dig into some of those features. But I'm also going to cover sort of what an Ingress controller is, why it works, and we're going to install this from scratch. So hopefully, if you didn't catch that earlier episode that we did on Contour, I can catch you up. I think I probably went deeper in terms of how load balancing works at scale there. But hopefully, we're going to go a little bit deeper into why I'm so excited about what's going on with the latest versions of Contour. And so let's see. So we have, Travis from Buffalo, Carlos from Havana. Awesome. All right. So, but one of the things we like to do as we start this out is to sort of cover the news of the week. And so the big news, obviously, this week is that IBM is acquiring Red Hat. So Red Hat was one of the original early partners with us as we launched Kubernetes. So I was at Google on the founding team for Kubernetes. And Red Hat has been an amazing partner the whole way through. Along the way, they purchased this company, CoreOS. CoreOS has also been heavily involved, or was heavily involved, in the Kubernetes world. And so a lot of Kubernetes expertise and community members ended up getting rolled up through Red Hat. And now they're all moving to IBM. What does this mean? Well, number one, it's a lot of money, $34 billion or something like that. That's a lot of money. And and Red Hat obviously does a lot of things, OpenShift and Kubernetes being one of those things, but you can't help but think that Kubernetes actually played a big part of this deal in terms of creating a lot of value here. So here's hoping that whole integration goes well and everything goes smoothly there, because obviously these things can be a little bit stressful for folks. And we're really hoping that, and every indication is that the commitment to open source will continue. All right, so like Lamatti says, I'm scared for the acquisition, think there will be a mass exodus, curious what this does to Fedora and CentOS. Yeah, I don't know what it means for Fedora and CentOS. I can't, you know, I haven't heard anything specific there. With respect to Kubernetes, even if we do see folks leave, and we did see that, you know, there was definitely some churn as CoreOS joined Red Hat. A lot of those folks found, you know, places at other companies that continued to work in Kubernetes. I think one of the things that we've tried to do as a community is to make Kubernetes be something that, you know, transcends vendors. And so, you know, we do see a lot of folks sort of switching between companies, but the constant is that they continue to operate and work with the Kubernetes community. And so that provides a little bit of a buffer here. Would Heptio get acquired by IBM? Well, I think IBM just spent a lot of money, so, you know, I'm not sure whether they're looking to buy more. So I have no comment on that. And then Sen is blue IBM mixed with Red Hat is purple. Yeah, change the logo to purple, something like that. I don't know. It's pretty clear that, like, you know, IBM's the one buying Red Hat, but the promises are is that they'll continue to operate relatively independently for a while, and so we can hope that that's definitely going to be true. So, yeah. So, you know, again, it's like these things, there's always a lot of really, really interesting things coming out of this. All right. So, and somebody's posting a video there. Let's see, in the HackMD. So this is a little bit of an experiment. Hopefully folks will be respectful and not post random stuff. Am I getting Rickrolled? I think I'm getting Rickrolled. Does anybody know like the Rickroll URL from scratch there? All right, so so that's great. Let's see. Oh wait, I have to switch to the screen there. So we had. Let me close some stuff here because I'm going to be talking about this. But we have. Oh, there's a full interview there. Okay, awesome. With so there's the press release, and here apparently I can play a YouTube video while watching you. Oh, I get an ad, but there you go. All right, so moving on to more news. Kubernetes 1.13 code slush is happening. So the idea here is that as we go through releases with Kubernetes and we try and get quarterly releases out, there's a schedule and we try and keep to that schedule. And it's important because that means that if a feature doesn't miss a release, like there's some stuff that Heptio folks wanted to get into 1.12, we missed the boat. We're spending the time to get those things into 1.13. And what happens is that there's it's sort of like a last call for changes before we go into code freeze to be able to lock this stuff down. The fourth quarter release of Kubernetes, which is what 1.13 is going to be, tends to be a shorter schedule because of the holidays, and so so that whole time gets compressed. So that's happening now. So and then this is also around now is when folks start pulling together the release notes. We see what's happening, you know, and try and pull out the big themes of what folks have been working on. So yeah, so that's going on. And so all the details around this is going on here, so you can check that out. Let's see, related is that there is this discussion starting around creating an LTS version of Kubernetes. How's it going, Carlos from Raleigh? Good to see you. And so we ship, like I said, Kubernetes ships quarterly. Support in terms of patches and security updates goes back 2 versions. So once 1.13 is released, it'll be 1.12 and 1.11. That'll actually be in scope. For a young, very dynamic project, that whole thing you know, makes a ton of sense because you want things to move fast. You don't want to be supporting a lot of old code. Kubernetes is getting to a maturity level where it really starts to make sense to, like, let's have something that'll be relatively static, a fixed target over a longer period of time. And so there's a lot of discussions going on here. You can start looking at some of the stuff going on in terms of what an LTS would mean, how long it would be supported, how often we would cut a new LTS. And so some interesting stuff going on there. Yeah. So just be aware of that, and I think this is definitely a pain point for folks that in more traditional IT roles, they don't want to be upgrading a Kubernetes cluster every 3 months. All right, Robert from New York, good to see you. So that's exciting. So KubeCon is coming up in December, which is very exciting. So we're going to have a booth there. We have a bunch of exciting things planned. I'm not going to spill the beans yet. If you can make it to Seattle for KubeCon, that'd be great. One of the things that's happening in association with KubeCon is a contributor summit. And this is a way for folks who are heavily involved in the community. It's not a user summit, so this is really about folks who are interested in the future of Kubernetes, contributing to that, and really moving things forward. Now, what I will say is that it's full up now. There's a wait list. George, who's on the line here, works for Heptio, is involved with Contribx, has helped to organize some of this stuff. But we will be going through and making sure that we record a bunch of this stuff, especially the stuff around new contributors and getting new people into the community. That I think will be good, and in terms of getting new folks in, if folks who are watching want to start getting more involved in terms of contributing to Kubernetes, that's definitely something that the Contribx SIG, the Contributor Experience SIG, would be really interested in hearing about. So is the Contributor Summit free? I believe that it is. I mean, it's associated with KubeCon, but I don't think you necessarily need a KubeCon ticket to be there, assuming that you were able to get in on the registration there. All right. So Carlos was saying Knative, talking about LTS, cutting releases, how often. That's really interesting stuff. It's a tough thing to do because you want to move fast, but you also want to give some level of certainty. Christopher from Germany, good to see you. Bo Hunch, I'm sure I'm butchering your name. Hello. Rodrigo from Montreal, that's great. Is there going to be a TGIK night at KubeCon? We have some stuff planned around TGIK. I don't think that we have a meet planned after hours or anything like that, but we're definitely going to be doing some stuff at the booth around TGIK to definitely get folks there. All right. And then, yeah, Nadir said he went to the EU Contributor Summit and it was good. And so, yeah, and the Contributor Summit is free if you were able to get registered there. Tarun from India, good to see you. All right, let's keep going through our notes. Okay, so there's a couple of projects that I keep my eye on that are new. Some of these are new to me. They're not necessarily new. The first one is this project called Gravitational Gravity. This is, and I haven't had a chance to dig into this, but the Gravitational folks have been working with Kubernetes for a while. The original theory behind their company is to create sort of a way to take SaaS-like offerings, deploy those on-prem. Gravitational does it. There's this other company another next project that I'm going to be talking about called Replicated that does something similar. But they have this thing called Gravity, which is a packaging solution for on-prem deploys and takes a snapshot of a Kubernetes cluster. So I think instead of looking at an app, it's looking at the cluster in general. I haven't had a chance to really dig into it, but it looks super interesting. One of the interesting things is that when people say on-premise these days, they don't actually mean something that's sitting in a corporate data center or in a colo. Sometimes on-premise might mean running in somebody's private VPC on AWS, for example. So I think a lot of times, when I say on-premise, I try and differentiate between saying behind the firewall, which means that you don't have access to it, it's being self-managed, versus truly on-premise in terms of some sort of non-managed data center. So similar to Rancher, I don't think similar to Rancher. Rancher, the whole idea of Rancher is to be able to deploy a Kubernetes cluster that you can use as a general purpose thing. I believe that Gravity is about application deployment, where you want to deploy an application, that's the thing, and Kubernetes is really sort of block and tackle part of deploying that application. It's sort of the embedded Kubernetes to some degree, when you think about a distributed application. Yeah. So Ali from Sweden, hello. All right, and then the next thing that I wanted to talk about, and I found out about this, and I want to play with this at some point too, is Replicated, which is another company that does this sort of help you deploy SaaS type of stuff. I was on a panel with those folks a little while ago. They created this thing called Ship, and this is a it's an experience, and by experience, I mean it's like a tool set that's built around sort of taking a Helm chart, filling out the things, creating the template, rendering that, and then being able to do customizations on top of that with Kustomize. And this applies both for Kubernetes manifest, but also Knative because it's built on top of Kubernetes. So that's actually really interesting. And there's a couple of things that they do here, which is interesting, which is that they have a, I don't know if they have, yeah, they have actually a, here's their flow. When you run it, they actually run a local web server, so you actually get like a UI that you can use to actually configure this stuff pre-ship. And then this thing is all compatible with like a GitOps flow, so there's no tiller involved. They use Helm template without using tiller. And I think we're starting to see more and more folks are like, hey, you know, I can get 99% of the value that I need out of Helm by using Helm template, using the charts, evaluating them, generating the YAML, without having to use tiller to actually submit that stuff. Bojan said, can you recommend something for testing Kubernetes, something like unit test or testing in general? So what do you mean by testing Kubernetes? Making sure that your cluster is working well? Because then I think, you know, what like Carlos said, there's Sonoboy, which is a good thing there. If you're talking about testing an application that runs on top of Kubernetes, you can keep a cluster up. If it's something that really gets invasive with the cluster, I mean, we'll do things where we have CI/CD where we use something like AWS to dynamically spin clusters up and down so that we can test against them. So yeah, some more detail on what you're thinking around testing there would be helpful. All right, so those are the projects that and sort of news and that I wanted to call out. All right, so the other thing we're going to do is we're going to start giving away some Heptio swag. We don't have any TGI specific swag yet. And so we have a link here, which is j.hep.io TGIK roll call. Now, don't go and fill out anything there yet. But what I'll do is and George, can you remind me about, like, you know, halfway through the TGIK, we're going to come up with a code word. If you use that code word when you do that, then I'll know that you actually watched the TGIK relatively recently. And yeah, I'll give you the code word later. You got to stick with me for a little bit. And then what we'll do is I think we said 48 hours, but I'm going to actually change this to let's add another 24 hours there for 72 hours. So we'll do 3 days. So if you watch TGIK within 3 days of broadcast and you submit it, then you'll be entered in to be able to get some swag. And we're going to send out 7 sets of swag. So is that link working? I think that's working. Yeah, hopefully you all can see that and click on that. And so when you click on this looks here. What you'll do here is you can put the code in here. If you don't put the code, you're not eligible. And we'll get your email address here. You can decide whether or not you want to opt into our mailing list. Feel free to say no, but if you want to get some good stuff, that would be great. One submission per person, please. Come on, don't game it, otherwise we can't do this stuff. If you give us a valid email address, then, well, number one, we can't contact you to get your address unless you give us a valid email address. But we also want to do this thing where if we collect email, we want to, you know, that's a valuable thing to us as a business, as a startup. And so we're actually going to donate a small amount of money to Black Girls Code to be able to, you know, in your honor, if you give us our email, which is one of the things that we've been doing as we've been running these marketing campaigns. All right, so stay tuned, and we'll talk about that, and we'll do the code in a little bit. All right, so let's talk about Contour and Ingress. Any last questions before I start digging in here? All right. So I'm going to start with defining what Ingress is in the Kubernetes context. It's one of these things where it's a weird name for Kubernetes. Kubernetes has its own terminology on stuff. Ingress is one of those things, so I'll try and decode that. There are with Kubernetes services, right? And that's one of the sort of fundamental things that we built in from Kubernetes from the get-go. There's a TGIK on that if you want to learn about it. There's also, you know, in the book I wrote, Kubernetes Up and Running, there's a lot of good background material there around services. We don't have Ingress in Kubernetes Up and Running, but it's something that we're looking at for the second edition of the book. So services operate at the sort of raw TCP level. So it says, hey, if you get a TCP connection coming in, forward it over there. And that can work pretty well. But plumbing in a new TCP incoming socket into your cluster can be expensive and difficult depending on how your cluster is set up. It can be expensive if you're using the cloud because you essentially have to allocate another load balancer, cloud load balancer, and the cost of those things can definitely add up over time. And but if you're running on-prem or if you're running with sort of other special needs, you may need to file a ticket or configure a hardware load balancer, do something to be able to actually have it be able to send traffic in. And so what that means is that a lot of times if you want to say host 1,000 applications on your cluster, you don't want to be allocating 1,000 different incoming load balancers. You'd want to be able to create that once and then leverage it across a whole bunch of different applications. So while it says Ingress was the difficult task in the CKA exam. Okay, that's interesting. Yeah, so Ingress is also kind of honestly half-baked. It's still early on, and one of the things that we're going to be talking about today is the stuff that we did with Contour to be able to evolve Ingress, to be able to take it into a next step. All right, so you want to do one cloud load balancer, but you want to use it across a whole bunch of different applications. Now, the way that you would typically do this is that you would get a software load balancer or reverse proxy. These things are kind of mean the same thing. A software load balancer, and you would configure that so that it actually knows about all your applications. And so common things would be something like nginx or HA proxy. These things all can play this role where they essentially know how to listen on a single port, accept HTTP requests, decode what that HTTP request is in terms of the host name and the path, and then based on that information, redirect it to different servers. Those are called upstream servers. So now I always get confused upstream versus downstream, but upstream means that things come from outside into the load balancer to an upstream service. And I can switch to my dock camera, and this thing gets a little wobbly, but hopefully y'all can see this. Let's see. So the idea is that you have a user, and then he goes through the internet to your cluster. Okay, and there's a way with service of type equals load balancer. You can go through and expose this. So there's a, go watch the other load balancing talk if you wanna learn about that. And then this thing goes to your software load balancer. And then this could go through and talk to other various services. And so you could set it up so that, hey, if I come into foo.com, I want to go to this service. I'll do this 1, 2, 3. And if I come in at bar.com, I want to go to this service. And I come at like I don't know, moo.com, I want to go to this service. So you can actually set it up such that this thing knows how to dispatch to the upstream service based on qualities of the incoming HTTP request. Typically, this is the host name, but it could also be the path. And in extreme cases, you might do it based on a session key or based on the HTTP verb or something like that. Now, the problem here is that, let's say that you're doing this with nginx or HA proxy. This thing has a config file in their own funky language that tells it how to actually configure this. And this config file, when you're just doing across like 2 or 3 different upstream services, not a big deal. But what you don't want to do is sort of in the Kubernetes way, you don't want to have one file that everybody has to touch, because then what happens is like, well, you need to have special permission to touch that file, which means that now when you want to configure the load balancer, you have to file a ticket or reach out to somebody and say, hey, can you do this for me? And then they get it wrong, and then you go back and forth. And so what should be an easy task of actually setting up load balancing going to a specific service can turn into a half-day thing of wrangling, or even longer if you have to file a ticket, all because everything gets sent through this single configuration file. All right, so that's sort of the the world sort of pre-Ingress. The idea for Ingress, though, is that what you do is that instead of having a single configuration file, you actually have lots of configuration files. And these things, we would have used CR. Ingress was introduced in Kubernetes 1.1 before we had custom resource definitions, the way to extend Kubernetes. And so it was built in as a first-class object, but it's essentially a CRD. It's a document with a schema that ends up not being a whole configuration file, but it ends up being a fragment of a configuration file. And so then the idea is the software load balancer, which we call an Ingress controller, reads all these fragments of configuration, all the Ingress objects, and then compile those things together for configuring the software load balancer. And so along the way, what you have here is a common schema. So there's actually ingresses that are backed by cloud resources. There are ingresses that are backed by nginx, by HA proxy, all sorts of different ways. There's ones that are purpose-built, something like traffic, or Ambassador, which does an API stuff along with it. And then there's one that we did at Heptio called Contour, which uses Envoy under the covers, which is the same C++ based load balancer that Istio uses. All right, so where we're at is that Ingress provides a whole bunch of little snippets of load balancing config. These things get integrated in, and that configures the load balancer. Now, there's 2 or 3 problems with current implementations of this. So the first problem here is that the schema for Ingress, so these are Ingress objects, is not great. There's a lot of undefined behavior. There's a lot of capabilities that people want to do that are not exposed through that. And so what this means is that because there's undefined behavior, it's not as portable as you'd like. You can take one Ingress and you can use it on one Ingress controller and it'll do one thing. You can use it on a different one and it'll do something else. So that's not great. The second problem here is that there's capabilities that people want to do that are not well defined here. And so what's happened is that there's a set of annotations that modify the Ingress on the Ingress object. There's these set of annotations that are key value pairs with essentially like magic junk set into the values that change the behavior of the Ingress. We use annotations to do similar things in a bunch of places around Kubernetes, but I think they really are out of control with the Ingress world. And sometimes these annotations are actually shared across controllers, sometimes different controller types. Sometimes they're very specific to that controller, and there's no central registry of these things, so it's very easy to get confused in terms of what's doing what there. And then the second problem is that the Ingress object, the Ingress controller just generally looks across all namespaces and takes any Ingress that anybody has. And so let's say that we want this one to be at foo.com. And so we have an Ingress in this namespace for service 1 at foo.com. And then this is namespace 1, this is namespace 2, this is say namespace 3. And then namespace 2 says, you know what, I want to be foo.com. And so somebody inside of namespace 2 creates an Ingress document that sort of squats on foo.com. Well, now all of a sudden the Ingress controller is like, I don't know what to do. I got 2 things that are saying they're foo.com. Should I just pick one? And so what that means is that somebody in namespace 2, either intentionally or unintentionally, can go through and actually impact the Ingress for what's happening in namespace 1. And so there's no affordance in the current Ingress scheme to be able to protect one namespace from another. And so that's a real problem. And then the other thing here is that, the Ingress, because of all of this, these things can be pretty error prone. And so it's easy to push a new version of Ingress, then break things because there's no way to really test it out in an easy way because things are not as, validated as I think we might want them to be. All right, so does that make sense? So that's kind of like the state of the art with Ingress right now. Does anybody have any questions of that around that before I I move on to sort of what we've done with Contour. No, I'll wait for a second here. There's some delay, obviously, before because of the YouTube streaming. Okay, so Hele Jelly says +1 on unifying and validation. Yeah. All right. So first off, there's a couple of things. Path priority in terms of. Julian says, could you explain one more time about Upstream? Sure. So the idea is that network traffic comes in from the user. It goes to a software load balancer. Now, so this would be generally, let's say if you're running an AWS, this thing here would be sort of an ELB, okay? And then ELB gets routed through some magic that I'm not going to go into a software load balancer running in your cluster. This would be nginx with some configuration goo around it. And then nginx then takes that request on a request by request basis and actually picks a service to send it to. And it'll pick the service based on configuration that's sitting in that in the configuration for that load balancer. And so that configuration might say, hey, if you see a request where the host name of that request is foo.com, go ahead and send it to service 1. And so service 1 then ends up being the upstream service for this load balancer. And that terminology is that like this is considered upstream. I don't know why that's up, because I always draw the diagrams this way. So I would think that this is downstream, but this is just the way that people talk about this, where like that direction is upstream. It's very confusing to me. Okay, so did that clear things up for y'all? Down is upstream. That's clear. Yeah, I don't understand why. It's just weird. I mean, you could draw it sideways. I could go like this, and then upstream's to the right. But I don't think it works well drawing it this way, because you generally think about the request flow, and the request flow generally you would draw from sort of top to bottom on your page. All right, so paths. Okay, pushing invalid ingress routes, breaking updates for all the other ingresses, always fun. Yeah, so that's definitely. And then paths can collide and sometimes actually hide another ingress on the same host. And this is one of those things where where the behavior for how the ingress deals with colliding ingresses is underdefined. And so different ingress controllers will actually deal with this in different ways. Maybe have the ingress controller look at a text record in DNS for a parameter to provide the namespace owns the record, but I like what Contour does better. Yeah, so that would be one thing to actually do that map. And I'll talk about why one of the things as we develop Contour is we wanted to look beyond just restricting based on a host name, but also look across the entire URL space, so we can talk about that. So I got disconnected for a bit. So each namespace is a different tenant project in here. Exactly. The idea is that namespace would be a different service, different project, and you want to really protect those from each other. And so you could have ingress objects belonging in different projects. How concerned should people be about the double hop, the load balancer and the diagram, the software-based ingress? Is there a significant performance impact due to that? There can be. One of the things that you'll see is there's some other bouncing around that can go here. If you're working in the cloud and you get the right magic, then instead of using a classic ELB, we're going to set this thing up with an NLB, which is a TCP-based thing. And it actually, I believe, even with the NLB, it doesn't terminate the TCP connection. So this reduces latency. Because with a traditional ELB, the request comes in, it terminates it, it can do its own HTTP-based stuff, and then it forwards it on. And so having those back-to-back TCP connections can definitely add latency, whereas NLB is transparent to the network, right? It'll modify the packets, but it won't actually terminate the TCP connection. And so the AWS NLB definitely helps to reduce that latency hit. All right, so hopefully most of you are sticking with me here. So what we're going to do now is we're going to just go ahead and we're going to install Contour. So there's a bunch of reference links here that talk about what we're doing. But if we go to Contour and you go to deployment, there's a whole bunch of different ways that we can deploy Contour. The one that we're going to be doing is this called hostnet. And And actually, and this is how we're going to do NLB here, which is the newer sort of more network transparent. Oh, I got to switch back to my screen. I apologize. Let's see. There we go. Okay. And so, but also if you look in our docs here, there's a doc on deploying AWS NLB. And so this is the setup that we're going to be working with. Now, everything that I'm going to be doing will mostly work regardless how you do it. So there's other ways of installing Contour. And so we've tried to find the common ways and actually make those work. And so you start by cloning the Contour repository, and then we're just going to do a kube control apply here. And so, and let's see, there's Slack messages coming my way. Okay. Let's see, people are chattering. I assume George will let me know if there's anything important going on here. All right, so so what I have here is I have a cluster using the Heptio, the quick start for Kubernetes by Heptio, which there's a link in the on the YouTube page. But kube control version, we're doing 1.11, kube control get nodes. We have 2 nodes and then a control plane node. All right. All right. Thanks for adding that, George. All right. So now what I'm going to do is I have Contour synced here. And you can see that if I do this, now I'm going to run this first. And then you all know that, and the reason I'm going to run this is that it takes a while for the load balancer on AWS to actually come up and run. And so what I'm going to be doing now is going through that YAML that I just ran, because if you all have watched this in the past, you know that I have a bunch of stuff running here. Let's see. And yes. All right, so we're doing hostnet here. Okay, so we have 3 YAML files here, is that right? Oh, you know what? Did I? Let me make sure that I sync. I think there we go, okay. Like I said, we have 4 YAML files here. So the first one is creates a namespace for Heptio Contour, creates a service account. And to make Ingress work, you generally need some fairly invasive permissions, which I consider kind of a design flaw. Oh, and then we have our custom resource definition for IngressRoute. And so one of the things that you'll see here is that it defines the printer column. So when you actually go through, an IngressRoute is the sort of Ingress v2 that we created for Contour. And you can identify which columns you want to show when you do this stuff. And then there's also, you can put in OpenAPI v3 schema here so that there can be some validation of this stuff. So this is the common stuff that is common across all Contour setups. Let's see. So while it said the instruction is for AWS, if I would like to do that on-prem, what would be running without a Kubernetes load balancer? So if you want to do it on-prem, what you can do here is you can do something very similar to this, but when you come down here and when we get to our service, instead of doing type equals load balancer, you do type equals node port. And then what that'll do, and you can actually specify with the right YAML which node you want it to be. It means any node on your cluster, if you hit it on that port, it will actually hit this service. And so then it's up to you to figure out, you know, do you want that to be port 80? Do you want that to be 443? So yeah, that's the, yeah, and then you do the node port, and then anything that actually hits that will actually go through and be forwarded on to the Ingress. And so then it's up to you to figure out how do you get traffic to some nodes. Now you can do that across all the nodes in your cluster, or you can pick up a couple of nodes, maybe use taints and tolerations to separate them from the rest of the cluster so that your Contour is only running on those things. So there's some things that you can do to actually sort of set up a software load balancing tier managed by Kubernetes when you don't have something like AWS. All right, hopefully that answers that. Okay, so the next thing here is that we're going to install Contour as a daemon set, which means that it's going to be running on every node. Yeah, and then Gabriel says you can use something like Metal LB also, and it works with type equals load balancer. I haven't actually played with Metal LB, so I'd love to actually play with that at some point. All right, so this will be a daemon set. There's some like annotations to help Prometheus know what to do with it if you're using Prometheus to monitor it. And we're running, it runs host network equals true, which means that this thing runs outside of your container network. And in doing so, and so it's running directly on port 8080 and 8443. So you can also, because this is running with host networking, you can hit this directly and you actually don't need a service at all if you're doing that. So that'll actually go ahead and work. Host networking is a privileged thing, but you'll also find that this will generally be less hops and lower latency when you do this stuff also. And then what we run is we run Contour, which is all the configuration goo. It essentially is the adapter from Kubernetes to Envoy. And then we're running Envoy here also. And then there's an init container that bootstraps the configuration for Envoy. And so Envoy is a C++ thing that actually does sort of like all the package, schlepping around, where Contour is the thing that talks to Kubernetes and then configures Envoy. All right, and this stuff is all pretty standard. And then it's running under a service count. And then we have RBAC. And so we have a role where you essentially get access to config maps, endpoints, nodes, pods, and secrets to be able to list and watch. And secrets is the big one here that's a little bit scary. And you need that because one of the things that Contour can do for you is to terminate TLS. And so it needs to be able to read secrets across the cluster to be able to read out the TLS keys so that it can actually terminate those TLS connections. And so there's that, and then services, it needs to be able to get, list, and watch services. It does the same thing for Ingress, and then it also deals with Ingress routes. And it'll actually go through and do an update, so essentially writes to Ingress routes so that it can actually write status into those things, and you can see what's going on. All right, and then finally the service. So this is actually how do you plumb things into Contour. All right, so if we do this, control get all namespace Heptio Contour, what you'll see is you have the daemon set it's running. We have the two pods, one on each node, and we can get services. Oh, what? Why did that not work? Oh no. Oh, how did that not work? Oh, okay, now we got to wait for the NLB to come up. Somehow I missed that. Cool. All right, so we're going to wait for that to spin up a little bit because that takes some time. Let's see, so we got that. And so now what I'm going to do is we now have this. So I'm going to actually go into Route 53 here. And I have tgik.io. And I have a CNAME here. So I'm going to program DNS for this. And I'm going to create a record set, which is the Apex one. And you have to create an alias, right? Where's the pointer text, blah, blah, blah. Wait, isn't it? Oh, alias, yes. Which is a different thing here. And CNAME. I think that's what I want to do. Routing policy, simple. Okay, create that. Maybe an A. There we go. Okay, so we got that stuff going. All right, so now we have that running. And if we go and if we look at EC2 here, and if we look at load balancers, there's one for the API server, But then we have this one, and you can see it's in like provisioning state. And it takes a while for the NLB to be able to work. So Aliciano Petrini says, I see that issue number 21 is not solved yet, which would allow to use the Ingress controller with external DNS, for example. Will this be solvable? So I don't know. I'll take a note here and I'll ask Dave about 21. We're putting together the roadmap for the rest of the year of what we want to do with Contour. So I'll see what the problem there is. And then would it be possible to make Contour work with traffic or HA proxy instead of Envoy? Not really. And I think what's interesting about Contour is, and Envoy essentially, is that Envoy is the data plane. So it's the thing that processes packets. And the thing that knows how to actually talk to Kubernetes is separated out as a control plane. And so one of the deployment examples here, and this is more of an advanced deployment example, if we look at this hostnet split, this is for a really scalable deployment. What you do is you actually run one deployment of Envoy, which maybe you run as a, you can run this maybe as a daemon set, but then you can run like a deployment with 2 replicas of Contour. And so you can essentially amortize that cost of actually running those controllers such that you such that the individual load balancers are separated. And so the way that works is that Envoy essentially has a whole API surface area where it then reaches out and talks to Contour, the Contour process, to be able to say, give me my configuration. And that API is not supported by either of traffic or HA proxy. One of the things that we are looking at doing is taking the libraries and the ideas around IngressRoute and working with SIG Network to maybe make this be an evolution of Ingress so that other Ingress controllers can implement the same IngressRoute. So they could go through and reuse some of the code in the libraries in Contour to be able to do that if they so choose. I know that there's been some interest from different quarters in that. All right, the swag code, since we're about halfway through, the swag code is IngressRoute. So if you go to, let me go ahead and I'll type it here. Here, I'm going to put myself in there. So j.roll call. And so go here, IngressRoute. There you go. That's where you stick that. So if you could go ahead and do that, that would be awesome. And we'll definitely, we'll pick some winners and we'll send you some swag. All right, so is the working Contour proposed as a V2, the Ingress API in Kubernetes? I mean, yes and no. I think we have a bunch of ideas here. We want to prove it out, get some experience. We're not going to say that, hey, this should be, Ingress V2, but I think there's some good ideas here that we want to use to inform that discussion as we continue that design. And I know, just got some email from Tim Hawken, who's the lead of SIG Network today, about that, and he's definitely interested in picking some of this stuff up again. Marcus, does Envoy Contour support Proxy v2 protocol supported by NLB? I don't think NLB does the Proxy v2 protocol. I think that's ELB with the TCP mode to be able to turn that on. I think it supports it, but I'm not sure if it supports the Proxy protocol. Okay, so for those who aren't familiar with this, with something like AWS ELB, what it'll do is a TCP connection comes into the ELB, and then the ELB terminates that, and then it creates another TCP connection going out the other way. And in doing so, the from IP address from the connection of the then receiving thing is going to be the load balancer, the ELB. And so there's this proxy protocol. It's called Proxy v2. It's kind of poorly defined, where essentially instead of being a raw TCP connection, there's a little header that gets put on top of that says, well, here's the original source IP address of this thing. And so that's called the proxy protocol. If ELB is operating in HTTP mode instead of TCP mode, then what it'll do is it'll actually start adding some headers on top of it. And Envoy will add those headers also. And what you'll see is with using NLB with Envoy, we actually don't, we'll actually see the true incoming request. Jelly says, can we reference TLS secrets from another namespace? No, you cannot do that, I don't believe. And then I'd love to see 509 close so we get cert manager support for IngressRoutes. I think the idea is that put that on the roadmap for Q1. So that's definitely something that we've been looking at. All right, let's go through and let's test to see if things have come up. So I have a sample application here in deployment example. And so cube control apply -f quard.yaml, and we'll look at what this is. So this is plain old Ingress. And so what we should see is if I do to tgik.io, there we go. We are up and running. Okay, and so I'll go through the YAML here in a second, but just with respect to NLB, what we'll see here is that X forwarded for is, this is my IP address for our office here in Seattle. And so this is the IP address, the from IP address on the connection that Envoy gets. And so it then goes ahead and hoists that into a header. And so with NLB, you reduce the number of hops. With NLB and host networking, you reduce the number of hops so that you actually sort of really optimize that path here. All right, so there we go. We got that up and running. Let's look at that YAML real quick just so that we know where we're starting from. What we have here is we have a deployment of my little daemon that I wrote for Kubernetes up and running called quard. We have a simple service running to that. The service is on port 80, retargeting port 8080. And then we have an ingress that is essentially a catch-all ingress that says anything coming in, doesn't matter where, send it to quard on port 80. And so the ingress sends to port 80, the service maps from 80 to 8080, and then quard is listening on 8080. And here we go. We are up and running. Okay, so that's kind of cool. So we have that working. So, but I'm going to take that down. Cube control, and we have. I'm going to start talking about IngressRoute. So we're going to do same thing with IngressRoute. So cube control apply -f quard IngressRoute, and then similar, but instead of an ingress, we have an IngressRoute. Oh, and actually this says quard.local. We're going to go quard.tgik.io. And then we're going to apply that. There we go. And this says, okay, anything coming to this host, match the route and forward that onto quard port 80. So this is essentially the equivalent here. And if this all worked fine, then we can do quard.tgik.io, and boom, there it works. That's awesome. So that's exciting. And so we can sort of, do a little bit of compare and contrast here to actually see how these things are different. One of the things that you'll see here is that we have virtual hosts, and then we have the routes that this thing goes ahead and matches on. And then one of the things we do, cube control get IngressRoute. We can see, look, there it is, and here's the fully qualified domain name. And this is the first route that you see. There might be more there, and we see that the thing is valid. Because we'll actually update status. Dave spent a lot of time adding status updates to IngressRoute so that if you see things go wrong, you can actually try and debug it. We can do OYAML here, which you can see that the status says that it's a valid IngressRoute, which is pretty cool. And let's go ahead and break something. Let's see if I send quard foo. What happens? Still says it's valid. Okay, because it's valid. It's like I could create a service called quard foo at some point. Let's see, how can we actually make this be invalid? Oh, if I actually remove the virtual host here, So what this says is that, hey, you didn't specify a virtual host, and so this is a free-floating snippet of Ingress configuration. So it says its current status is orphaned. It says this ingress route is not part of a delegation chain from a root ingress route. All right, so I probably just confused you there a little bit, but we'll get to that. But that's the sort of like where you'll actually start seeing some errors pop up here. All right, so we're going to go ahead and put that back, apply it again, get the status, and we see that it's now back to being valid again. And so this stuff reconfigures really, really, really fast. One of the nice things about Envoy, based on the way that Envoy is written, is that it's built to be dynamically reconfigured. And so with these APIs, they get configured right away. Whereas I think something like the nginx Ingress controller, it actually takes your snippet, it actually literally writes it to a file, and then it goes through and it tells nginx to reconfigure itself. It does that by spawning and then leaving the previous version around to handle any connections that are incoming. And so the result is that if you end up with a high churn rate of your ingresses or services, and you have longer lived connections, you can end up with quite a few of the nginx processes still around, and that can become a resource hog and become problems. So Walid's saying, Mike Merrill, is a code available? Oh, so Mike was saying that he wrote a controller to copy around their wildcard certs so that they can be available across a lot of different namespaces. And Walid's asking, hey, is code available on that? One of the things that I think we can do here, and this might be, and I'd love for Dave or maybe Steve if he's on, is that with IngressRoute, what you can do is you can have the host names, the root terminated in one namespace, and then you can actually go cross namespace to be able to deal with the rest of your Ingress configuration. And that's something that we'll be able to actually dig into a little bit later here as we go through these examples. All right, so we're starting off slow here. So that's pretty simple stuff. And I'll go through and take this back down. All right, so now what we're going to do here is if we go into deployment and we go into example workload, IngressRoute, there's a whole bunch of really interesting scenarios here. And if you go into some of the blog posts that were linked off the HackMD, so Steve says you can limit where TLS certs live and delegate routes to different namespaces. So yes, you can essentially terminate with TLS in one namespace, and then you can have the rest of the configuration be done elsewhere. So that might be a solution to not copying these wildcard certs around, and probably, you know, in addition, you could probably limit the RBAC scope that Contour needs to just reading secrets in that one root namespace. But we'll talk about that in a second as we get to this stuff. All right, so there's a bunch of common stuff which creates a namespace, because we have the default namespace and then we have another namespace for your marketing department, say. And then it creates a whole boatload of services that talk across these things. Now, I haven't gone through this stuff before, so I'm coming at this kind of cold. I ran out of time to actually prep, so hopefully I won't get myself stuck. And then we have a couple of deployments, one into the marketing namespace and one into the default namespace of QuarD. So we'll go into IngressRoute, cube control apply -f this, which, oh, that work? Why? Oh, 00 common. There we go. Yes. Okay. So we created a bunch of services and some deployments. Okay. And it's okay. Yeah. And so there's an okay. So, but we haven't created an ingress yet. And so the first thing we can do here is that here's just a simple basic ingress route. And so we already did this with the previous example with QuarD, so I'm not going to do that one again. The next thing we can do is a name-based ingress route. Okay, so here what we have is if you want to do multiple host names, you can split that across multiple ingress routes. So all I was saying, I don't think the notes from last time made it on the master branch on GitHub. Yeah, there's a task for George and Chris to clean that stuff up. I was just giving them a hard time about that. All right, so we can go ahead and do this, but this is pretty straightforward, so I'm not going to bother doing this. And then similarly, I don't have Cert Manager set up here. You can do the same thing with TLS where you can actually specify the secret name to use. And there's this assumption that like, hey, you're just using the same. So it reduces some of the copy and paste that you generally need with Ingress for TLS. So this is a TLS example. Okay, Roy says, can it, i.e. route specific requests based on specific request headers? I know Envoy can do a lot, but what is exposed with Ingress routes? I don't believe that we do things based on specific headers. I think that that's something that might make sense. The idea here is that there's a bunch of different sort of selectors that we can do here. Having a header selector here as part of the route totally seems like it would be a reasonable extension to add to this. One of the other things, I mean, we're going to have to figure out how to do it with, we can also do load splitting between two different services. And so we'll go ahead and play with that eventually because we start seeing that with the blue-green stuff here. So now here's where things get interesting. So what I'm going to do here is, let me find this code, delegation across namespaces. So we're going to go through here and we're going to have quar_d.tgik.io. And what we're going to do is we're going to if something comes into quar_d.tgik.io, if it matches the root, it's going to delegate to service S1. If it matches /service2, it's going to delegate to another ingress route called service2. And so in this way, one ingress route is referencing another ingress route. Now this one is called a root ingress route because it actually has a virtual host on there. Whereas service2, when we look at this, there's no virtual host. And so this thing will only be used if it's explicitly linked into the delegation chain. So let's go ahead and we'll apply these things one by one here. O2, 03 basic. Okay, so we'll go ahead and do this, and we'll do kube control apply -f root. So we go ahead and do that, kube control get ingress routes, and it says, okay, this is a valid ingress route. So, oh, did I hit save here? I forgot to hit save. Okay, let me go ahead and apply that again. And here we can see that we have quar_d. I can click on that, and boom, there we go. Everything's working just fine. Okay, but if I go through and let's go through, if I go through and if I actually try and go to service 2, I'll get a 404 page not found. All right, so now if we go through and if I do kube control apply -f service 2, now if I see this, I'll see both of these things, and we can see the first route on these things and the qualified domain name and all this stuff, right? Now, one of the things that we want to do eventually is we want to build some tools that can actually help you visualize the connections between these things. Because right now I can go through and I'm saying, hey, this thing links to this thing, but really what we want to do is draw a picture. So let me go ahead and I'll draw the picture for you. But we really want to get to the point where we can visualize this. Now, it turns out that there's an internal model that Contour keeps, and we have some visualization around that. But we'd really like to have some visualization over what users actually see. So we have one ingress route that has FQDN of quar_d.tgik.io. Excuse my handwriting, but you know what I'm saying there. And then we have two routes. We have one route going to S1, and then we have one called service 2 And this thing goes to another ingress route. And so this doesn't have, it has no FQDN. This is called service 2. This one I think is called root, right? And then service 2, let me make sure I get this right. This thing then has, it has slash service 2 goes to S2. Okay, so you'll notice that this is still anchored to the root here. One of the things we talked about is maybe having these be relative, so that if this thing were just like a dot, then it actually would say it mounts into service 2 like that. We're still figuring out exactly whether we want these things to be relative or not, or whether that'll confuse the heck out of people. So hopefully that makes sense. If we go back here, one of the things that we can see, yeah, and both of these are marked valid. Okay, so now if we go to here and we go service 2, oh, we're still getting, oh, I didn't apply it. Oh, wait, I did. All right, so what's going on here? So this is going to S2. What am I doing wrong here, Steve? Steve, is this supposed to work? Do you know? I think it could be that QuarD doesn't actually like this. I'm not sure if QuarD likes this coming in at a different route. So it's not rewriting the path. Is there an extension to have it rewrite the path? I'm not sure if that works. Again, I haven't had a chance to go through this, so I think this example might not work well. Yeah, so we're getting a 404 from QuarD. Let's go through and I know that there's another example workload that Dave likes to use. What does he like to use? He likes to use deep hit. What's the one that Dave likes to use? It's escaping me right now. It's like HTTP debug thing, right? HTTP bin, yes. I bet he has it buried in here somewhere. All right, so we'll do, there we go. Cube control get deploy. Oh, and then service 2. Okay, so, all right, we're going to do some live debugging here. Stay with me. I apologize. So we have deployment, and then we're going to this is going to be HTTP bin. And then this thing, we got to do this stuff here. YAML's mad at me. All right, so we'll do that, and then the service is S2. We're going to go to HTTP bin. Okay. HTTP bin is invalid. What did I do wrong? Selector does not match. That is on the deployment. Okay, so what did I do? Sorry, y'all. I'm being, All right. So now, did I leave the QuarD label on purpose? No, I don't think I did, but okay. So this thing is there. Now the service for S2 is now going to HTTP bin. Namespace default service S2, port 80, 80, 80. So I can add a prefix rewrite to the route, but like I will get there, but I want to make this work now. I'm getting obstinate about this. So, okay, so this should work. All right, that's a different error. Okay, so now what is the oh, Aliciano, don't shut up. It's fine. It's fine. Don't worry about it. So there's the prefix rewrite. We're going to go ahead and we're going to fix this. Okay. Okay. So now we're going to go here and we're going to go to the delegate one and we're going to go through and where does this actually go in there? This goes into IngressRoute. There we go. Okay. All right, so I'll explain what's going on here in a second. All right, good. Okay. So there we go. All right, so what's happening here is that when we go here, we'll go to QuarD and everything works. But if we go to service 2, it'll actually redirect to HTTP bin. And then what we can do is, wasn't HTTP bin supposed to actually do a whole bunch of other fancy stuff? But it'll go through and it'll rewrite service 2. So this service, HTTP bin, is just seeing a slash. So it's just seeing this, right? The typical rewrite problem with apps not ready for being behind a slash whatever. That's exactly what happened here. So Julian says, how to hire people for Kubernetes, give them a YAML with a typo in it and watch how they react. Yeah, unfortunately, that's sort of the world that we're in. So how do I configure HTTP bin to do fancier stuff? I want to do that. I thought that there was like because Dave always has it with like really fancy stuff. HTTP bin app, I guess that is what it is, right? Yeah. All right, well, we got it working, so at least we now see that thing going. Try service 2 headers. Yeah, let's see if we can do that. There we go. So we can start seeing all the stuff that's coming in. And here you can actually see that we see the Envoy external address coming through. It looks like it actually maybe scrapes or removes the other address. I'm not sure. And oh, we also have original path here. So here we can see the original path that this thing is seeing. And yeah, cool. I thought there was a way where it listed all the different things that you could do there, but oh well. All right, so that's really interesting because now what we can do is we can go through and go across this stuff. I want to like HTTP bin. What is this? Yeah, like I didn't get all this stuff here. Why is this not working? Oh, you know why this isn't working? Because it's all dynamic and it doesn't like actually being re-hosted. Ah, so that's what's happening there. Yeah, so it got upset about it. We're too fancy here. So generally, if you're going to host things under a path like this, they got to be ready to do that stuff. So yeah, so now this is like now a single page app. So it actually goes through and actually gets all these things. And so that's what we're seeing going on here. Whereas like what I can do here now is I have another ingress route. Let's go through and Cube control. Let's go through and touch http bin dot IngressRoute.yaml. We'll go ahead and we'll actually create another one of these things at the root. And so you can host this thing from different directions. We can do. So we just created another route there. Now if I go to http://bin.tgik.io, there, now we got the whole deal coming. Yeah, so path rewriting can sometimes be really problematic. You really need to have everything sort of be ready to be hosted on something. Like a lot of times servers assume that they have the root. But you know, if your backends, if your upstream servers are ready for it, it can be a really useful technique. What is the best way to make multiple React applications work on subfolders assigned to each application? I think with React, and I'm not the expert here, there's a way to say, hey, you're being hosted under this particular path and have it react, you know, have it sort of configure itself automatically. There's got to be a way to be able to do that. So yeah, so cool. All right, so now we got HTTP bin hosted there, but we also have quard hosted. And we can go through and we can service 2. This also goes to HTTP bin, but this HTTP bin is all confused because if I bet you if I look here, we have a bunch of errors here because it's like, sorry, I can't find all the stuff that I'm looking for because it's not expecting, it's looking for it on /. It assumes that it's at the root. All right. So, all right. So now one of the interesting things, so the next thing that we're going to go ahead and do here is we can do blue-green deployments of your ingress routes because you'll have a tree of these things and sometimes you may want to be able to switch between them, which actually ends up getting super, super interesting. And so let me go through and let me take this stuff down. And we're going to now go into the blue-green delegation, which is super interesting, I think. Because now what we're doing here is we have one, we're going to do bluegreen.tgik.io, and it's now delegating to the thing called blue. And so blue is going to go to S2, which is going to be HTTP bin. And then green is going to be S1, which is quard. So we can actually see both of these things. Let me go ahead and save this. I can go through and do apply these. Now if I do a kube control get ingress route, what we'll see is that the blue-green route, that's working fine. And then blue is totally valid, but green, we're getting this thing saying, hey, it's orphaned. This thing's not hooked in anywhere. So it's essentially free floating. And so, so now I can go to bluegreen.tgik.io. Look at that, everything's working fine. I can, you know, go ahead and reload this thing all I want. And then I can go through and modify this. So now I want to actually switch to green. And so now, oh, let me do a couple of other things here. So what I'm going to do here is I'm going to create another ingress route. And I'm going to call this one blue route. And that's going to go to blue. And then I'm going to create one called green route. And that's going to go to green. Okay. So now what we have, and let me switch back to the dock camera here. So now what we have is we have an ingress route called blue, and this one has / going to S2, which is HTTP bin. And then we have one called green, and this has / going to S1, which is quard. And then what we have is we have We have Blueroot. And it has slash delegating to this. We have GreenRoute. And we have slash going to this. And then we have one called Bluegreen And this one, right now it has slash going to blue, but we're going to redirect it. Okay, Jeremy's, can headers be added in an ingress route? I don't believe so yet. I think that that's a great feature request. I know Envoy supports that, and that's something that we might want to be able to do. It can get a little dangerous doing that stuff, especially as you're delegating across stuff. I think there's some security implications that we'd want to think about, but yeah, I think that's super interesting. All right, so now what we have is this is Bluegreen, but if I go to blue.tgik.io, did I apply? Yeah. Okay, so now we're at blue. Everything's good. So here you can see everything is valid and everything has a route. And this visualization, unfortunately, is not that I drew. We should be able to auto-generate that at some point. But now I can go to green.tgik.io. And, all right, don't fail me here. And that'll take us to Quard, right? So we have our two versions of our application, blue and green. But now I have blue-green. That's currently going to HTTP bin. But now if I go and I go through and I switch this thing to green and redeploy and go back and reload, boom, now that same URL is going to the new version. And so what you can imagine here is if you're doing a blue-green deployment like this, you can have URLs that are headed one way and you can have URLs headed another way. You can canary stuff, you can test it out, and when you're feeling comfortable with it, you can switch things over. Bob says, lots of good stuff. Have you considered ASCII Cinema? You know what, every time I read that, I read ASCII Enema. I'm sorry. I like ASCII Cinema, but like you can't host it on like, I want to create GIFs that I can post on Twitter and stuff like that. And so ASCII Cinema or ASCII Cinema or whatever it is a little bit tricky from a sort of being able to share it point of view. Okay, so all right, so that's pretty cool. Now, one of the things that we can do here is, and I have to look up the syntax here because I don't remember it off the top of my head. This is, oh, let's encrypt. Okay, so here we go. We have the documentation for IngressRoute docs. One of the things that we can do here is that you can have multiple services. And let me find where that is. Routing. Ah, there we go. So now we can go through and we can go, or no, can I do it with multiple delegates? Can I do that? I don't know. Oh, I think I can only have one delegate, but then I can have multiple services. Oh, that is lame. Okay. All right, I thought we had this. I think we may. All right, we may want to evolve this. I'm gonna talk to Dave about this. Okay, but one of the things that we can do here, and I'll just go through, and instead of delegate, we're going to do services, and we can do. I can do multiple delegate. How do I do that, dude? Delegate. Delegation. So here we only have one. How do I do it, Steve? So Steve is one of the guys that wrote this, so he knows what he's talking about. Because I don't see it, there's no list there. All right, I'm gonna API All right, so we have services, and then we have delegate. Delegate is a name and a namespace. I don't think you can do multiple there. I think we probably want delegates, and you can actually do you can do a wait across that. Okay, so we'll cheat here, and we'll go services, and then I'm going to go through and actually steal this. And then we can go through and we can do name S2 port 80. So now if I go here, oh, I have to push this thing, apply it. So now it's 50-50 which one I get. And both of these things expect to be able to call back on the same URL. So they're both going to be slightly broken, but you can see that sometimes they'll work, sometimes they won't, because like each request is actually getting sent one versus the other. And then one of the things that we can do here, and so this way you can actually go through and, you know, if your services are compatible enough, which these aren't. In fact, well, here's what I'm going to do. Is I'm going to go through and I'm going to change my, I'm going to create another deployment here. HTTP bin, we're going to do, we're going to do QuarD2, and we're going to have this be version 2. This is why I did this stuff. Oh, we're doing, okay, so now we're back here, and now we have the blue-green. If I look at the root here, I'm going to send this one to, oh, I have to modify one of the services, darn it. We're going to have service 2 go to QuarD2. -F. And yeah, okay. So now, all right, so it's hard to see here. I should have made this like better, but like you can see there's a -2 there, and sometimes there's a -1, and sometimes there's a -2 in the demo application here. And so that's that different versions, -1 and -2. And so it's actually splitting traffic between these two different services. And not only that, but we can go through and we can weight these things. And so I can go through, and if I go and I look here in blue-green deployment, route delegates to A and B. A then contains a route to folder A, while B contains a route to folder B. How can we determine which delegate should be so when you delegate to something, there's essentially a decision path there in terms of which one do you want to go to. Contour makes sure that only one path, or that at each level, it's deterministic, or at least, you know, statistically viable in terms of which path you actually go ahead and take. If you try and do a cycle, then it'll definitely catch that stuff. So now what we can do is we can go through and we can do wait, and I can go through and I want to do, so now this is 100 to 1. The idea is that, well, we'll do 50 to 1, right? So this weight is 50, this weight is 1. You sort of do those things proportional. It doesn't have to add up to 100. We go do that. Now we should mostly get 2 here. We'll hardly ever get 1, but once in a while we'll get 1. If you see a lot of traffic, once in a while you'll go ahead and get 1. And let's see. So I think I'm running out of time here, but there's all sorts of other features here, but I think it's really interesting. And then, oh, and then the next thing that you can do, and I think, oh, why is this getting timeout? That's not good. Don't do that. Is that these delegations can actually work across namespace. And so I don't think we're going to have time to go into this, but let me draw that out for you so that you all can see sort of what things look like. This is the idea, and this is what we actually built for our customer who wanted to be able to essentially have a safe way to do this stuff. Oh, you need to specify a weight. Okay, no weight means 0. Okay, so the default is 0 for weight. Sorry, my mistake. So we'll do weight 1 there. Well, okay, we'll do 25 to 50. If I go ahead and apply this, there I got 1, but I'll mostly get 2. I'll definitely see 2 more than 1 here with that weighting. All right. Oh, wait, you guys didn't see that, sorry. So I went through and I changed it to this, where I put a weight of 25 here and I put a weight of 50 there. And then I applied that, and then when I reload, I'll get version 2, which you'll see up here, a lot more than I'll get version 1. So there we go. If no weights, it's an even distribution. Otherwise, the weights matter, and if you don't put a weight on something, that means no traffic. Okay, cool. So let me draw out what the cross namespace stuff looks like. So the idea here, and there's modes in Contour to help you do this, is that you'll have, oh, that's too hard to see. Let me do a fresh sheet. Is that you'll have a special namespace. So imagine this is all one big cluster. And you'll have a special namespace that'll be my Contour root namespace. And then for each of your top level domains, you'll have something like, you'll have an IngressRoute for foo.com, okay? And then namespace, and then this will then delegate over to maybe here's my namespace foo, and now I actually have an IngressRoute called, say, foo root. And so you have to coordinate the naming across these things. But the way that this works now is now you can actually sort of, send this to services. You can like delegate to, foo blue or whatever here that goes to service 2. You can do whatever you want in terms of this particular thing. But essentially, this particular route, this defines all your routes. And this is where TLS can happen also if you don't want to share all this. And then you can go ahead and send this stuff off to the other ingress over here across the namespace. Now, by default with Contour, anybody, all right, Steve, have a good time, man. See you later. Have a good weekend. Anybody can go through and establish a root namespace with a FQDN. Well, there's an option when you launch Contour, and that's documented, where you can say, hey, Contour, I want you only to look for roots in this one single namespace. So that way, if somebody actually tries and creates a root namespace inside of here, it'll either get ignored or you'll get an error out of it. And so that way, what you can lock down is that only people who have write access to Contour root can establish new roots in this thing. Furthermore, like this thing, foo, can actually go through and you can have a namespace called, say, foo v2, right? And you could have an IngressRoute here, and this could delegate, foo.com, or this can delegate its own thing, but we can actually have here, we can have this be the /v2 route that actually goes here. Or maybe this is API, and this is foo API or something like that. So you can then go through and then sub-delegate this even further across more namespaces. So it's really moving the control around configuration to different folks. And so it's kind of inspired by the way that DNS works in terms of its delegation. And so I think that's mostly what I wanted to cover. There's some more stuff going on there. We talked about multiple routes, so you can do canary-like stuff. So the question here was rate limiting. I think that would be great. Rate limiting is another feature that would be great to add here. But overall, If you go through these blog posts, they actually go through, describe some of what I actually talked about. Third-party auth is high on our list. So one of the things that we see in common quite a bit is that folks will want to do something like, create a portal where any application developer can come up and say, hey, I want to write an app. They then get a Kubernetes namespace. As part of that, they get an IngressRoute configured for them. That IngressRoute is configured with like appname dot, like internal foobar.com type of thing. And then by default, you want to make sure that like you don't accidentally expose, internal company information to the rest of the world. So you want to put something like an OAuth 2 proxy in front of it. And so that scenario where you want to run an Ingress controller where every access to that Ingress controller has to go through some sort of auth, that's definitely something that's on our radar because we think that that's a really important situation. So Jeremy is asking, how does Contour fit in with Istio? That's a really good question. Istio, it does do things that look a little bit like Ingress with these things called gateways. But the bulk of what Istio concentrates on is what we call east-west traffic between different services, between microservices. That's really the sort of the genesis of where the mesh comes from, the idea of a service mesh comes from. Whereas with Contour, we really wanted to solve the problem around northwest traffic, right? How do you actually get traffic into and out of your cluster, which is a different problem from dealing with that east-west traffic. We're looking at ways that you can run Contour and Istio at the same time. Unfortunately, Istio is not super extensible in terms of being able to have multiple things work together to actually configure the Envoy. But I know that there is some discussion, and I was talking with Matt Klein just this morning, who's the creator of Envoy, of trying to figure out a way that we can start making these things actually work well together. So Jeremy, is it crazy to want to use Istio for that northwest traffic or north-south traffic, I'm assuming? We are trying that for hybrid multi-cloud. I mean, I'm not an Istio expert, so I'm not going to try and claim that I have all the latest knowledge of what's going on. So one of the things that we looked at Istio, and this whole idea of delegating across namespaces, across the URL space, being able to actually control who has access to what ingress routes, that's something that was really, really important for our customers, and that's not something that Istio can do. And so the configuration for Istio is not, it's not written in a way such that it's compatible with Kubernetes RBAC in that type of way. So you can't restrict that Ingress stuff based on RBAC rules with Kubernetes. Looking at the Istio APIs, they have this idea of a virtual service, which is in some ways similar to an Ingress route, but there's no way to actually delegate or have one virtual service talk to another virtual service. And so it's really sort of like a one-tier type of thing, whereas we really looked at IngressRoute as being a logical construct versus something that, without any sort of decision-making gets rendered directly down into Envoy. So hopefully that answers that question. I have high hopes that we'll find a way to bring this stuff together. I mean, my ideal world is that we take something, either IngressRoute or something like IngressRoute. We use that to find Ingress v2. The Ingress v2 is good enough such that Istio can actually play along with that. I'd love to see Istio actually get the right extensibility hooks such that Contour can actually play a path with Istio also, and it's not sort of one, because right now Istio is a pretty, I don't want to say all or nothing because there are parts of it, but like it has a very opinionated way with how it does stuff like gatewaying in and out. All right, so that is that. I have to go. I've been talking for quite a while here, and my Diet Coke is empty. Thank you, everybody, for watching, and definitely, hit the like button, subscribe, and all that. Again, if you want some swag, there's TGIK roll call here, and the code there is IngressRoute. Please go ahead and put your name there and put an email address in there. And thank you so much for joining me, and we're not quite sure what we're doing next week, but I guarantee it will be exciting. And so I will sign off and see you all then. Have a great weekend.